I'll talk about the elastic head-on collision between two balls. So we have a ball here. The mass of the ball is given, which is 500 gram, and this ball is moving with a velocity of 5 meter per second. And then there is another ball, the second ball, which mass is 0.2 kilogram or 200 gram, and it is moving with in opposite direction with a velocity of 80 meter per second. And here I have included the negative sign, and the reason is because this second ball is moving in opposite direction to the first ball. That's the negative sign, and you have to include the negative sign, otherwise it will be totally wrong if you do not include it. And after the collision, the direction has reversed, and we'll talk about it later. So, and here this is a perfectly elastic collision. The perfectly elastic collision means the total kinetic energy is conserved and the total momentum is conserved. Both momentum and the kinetic energy conserved in the elastic collision and kinetic energy. And the one thing you have to remember, that in elastic collision, in a perfectly elastic collision, in a perfectly elastic collision, the velocity of the ball after collision is given by this formula. The V1 means the velocity of the first ball, and the F means after collision or final velocity. And here the V1I means the velocity of the first ball, and the I means the initial or before collision. And the V2 is the velocity of the second ball, and the I stands for the before collision or initial velocity. And M1 and M2 are the mass of the first ball and the mass of the second ball. So we are given all the information, we just have to plug in. The mass is given, which is 0.5 kilogram, 0.5 kilogram. M2 is 0.2 kilogram. V1I is 5, and here again I'm putting M1 and M2 values. And M2 is 0.2, M1 is 0.5, and M2 is again 0.2. And V2I is negative. Again, remember the negative is because it is moving in the opposite direction. That's why we have the negative sign. And if we plug in and solve it, you'll get negative. The negative has a meaning here. What is the meaning of this negative sign? The meaning is that after collision, this red ball or the M1 mass is now starts moving in the opposite direction. So you see now, we call this direction as a positive direction, and as the velocity has become negative, that means it starts to move in the opposite direction. That's what negative sign tells you. Okay. The same way, now we can calculate the velocity of the second ball after the collision, and this is the formula for calculating the velocity of the second ball after collision. So let's plug in all the values now. The 2 is a constant, M1 is given 0.5, M1 is again 0.5, M2 is 0.2, and the velocity is 5. And M2 is 0.2, M1 is 0.5, and plug in all the values, and V2I is negative 8. So if you plug in, you'll get 10.56 meter per second, and this is positive. So what is the positive sign means? The positive sign means after collision, the second ball direction is again reversed. It also reversed, and it starts moving in the opposite direction. So initially, before collision, the two balls were coming towards each other to hit, and after collision it is separating from each other. but there is a connection between, and there is a beautiful connection between that. The relative velocity of approach between the two balls, the velocity or the relative velocity between the two balls which is coming towards each other is exactly equal to the velocity of separation. So the velocity of approach is exactly equal to the velocity of separation. Or in other words, if the velocity of approach is 10 meters per second, the velocity of separation between these two will be exactly 10 meters per second. Let's calculate this one, or let's see it. So the velocity of approach, how do you calculate the velocity of approach? v1i minus v2i. v1i is 5 and v2i is minus 8. So I'm just calculating here for your, it is not required, but I'm doing here the velocity of approach. Let's calculate it. Is equal to v1i minus v2i. This is 5 and this is minus 8, so it will be 13 meters per second. That's the velocity of approach. And now let's calculate the velocity of separation. Here I'll just put the relative velocity. Of separation. The relative velocity of separation is v2f minus v1f, and if you plug in v2f, we just have calculated v2f is 10.56 minus v1f. v1f is negative 2.43, negative 2.43, and if we do the math, we'll get 13 meters per second. And you got the point now. You see now, let me highlight this one. So the velocity of approach is exactly equal to the velocity of separation. So before collision, the balls are coming towards each other with a certain relative velocity, and after collision they will separate from each other with exactly the same relative velocity. Okay, now let's go to the other part. Other part is calculate the change in the kinetic energy of the first object. So whenever there is a change, what the change means? The change means the final kinetic energy minus initial kinetic energy. That's what we call the change. So how do you calculate the final kinetic energy? The final kinetic energy will be half mv1 squared, because the formula for the kinetic energy is half mv squared. This is the formula. So for the kinetic energy, it will be half mv1f squared, the final. F stands for the final, and the I stands for the initial. And this is for the first object, so we're just taking the mass of the first object, which is m1. I think I will include m1 here, forget to m1. So half the m1 is 0.5, and v1f we calculated is negative 2.43 right here, and half m1 is again 0.5, and v1i is given, which is 5. So you just need to plug in, and once we plug in, the value we get is 2.47 joule. That's the change in kinetic energy. And what does the positive sign mean? This is positive. What the positive sign means? That means after the collision, this one starts moving faster. The kinetic energy has increased. It has more energy after collision. So now, as this is an elastic collision, what does this energy the first ball gets from? That means the energy of the second ball has decreased exactly by the same amount. So if you calculate the change in kinetic energy of the second object, it will be negative 2.47. and I encourage you to calculate it by yourself. Okay, and the total energy, the total change in energy will be exactly 0. That's what the conservation of kinetic energy means. Both kinetic energy and the momentum is conserved in elastic collision. The one ball gets more energy and the other ball loses energy. That's exactly is the conservation of energy. So this is it for the perfectly elastic head-on collision problem. And again, if you have any questions, any comments, any feedback, any suggestions, please write down in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you very much.